And we have Dr. Ian. Dr. Dank Oswald is an accomplished chemist specializing in cannabis aroma chemistry at Abstracts Tech, with a PhD in material science and over 35 peer-reviewed publications. His research goes beyond terpenes, uncovering new volatile compounds that play a dominant role in cannabis aroma. And Dr. Oswald's work with cutting-edge analytical tools like two-dimensional gas chromatography led to the discovery of canasulfur compounds, that's right, CSCs, pioneering new insights into the chemical complexity of cannabis. Today, he's going to talk about his new discoveries in the first of the Dank Lab series, you guys. And so how this is going to work is Dr. Oswald is going to present. Anyone in the audience watching this live chat and participating in that, any questions that you guys ask, the doctors will answer as well. If there's research that's posted to that, they will post the links into the chat. And if you are watching this video after the live show, those will all those links to all the questions and everything will all be in the description of this video, so then that way you can follow along with the research as well. And so without further ado, it is none other than Dr. Ian Oswald from Abstracts Tech.
Well, thanks, Jason, and everybody else. Glad to see everybody here. Yeah, so this is going to be the first in a series of just kind of short presentations over the next probably year, kind of quarterly, just summarizing some of the research that we are doing at Abstracts Tech. And so this will actually kind of start at the beginning of what we did, which is discovering some of the compounds that contribute to that gassy, skunky aroma in cannabis. And so, you know, everybody in this room and probably listening is aware that cannabis produces so many a wide diversity of aromas. And, you know, shown here are some pictures of buds that have come through a lab that we've taken pictures of, and some of the aroma descriptors associated with some of those. I'm sure many of these look familiar to many of you. But for a long time, the descriptor kind of gassy cannabis, that gas, or even the skunk notes in many varieties, it wasn't really well understood what the chemistry was there. And so I'll just briefly go over what that is and how we got to understand what the chemistry is behind those aromas. And so just really briefly, if we want to kind of look at broadly what the chemistry of cannabis is, the phytochemistry, at least the secondary metabolites, this is kind of simplified Sankey diagram that kind of illustrates this. And so we have cannabinoids that many people are familiar with, and probably like the most fascinating part of cannabis. There's other stuff such as waxes, lipids, canflavins, and whatnot. But at Abstracts, really what we're interested in is the aroma of cannabis and what makes it tick as far as the chemistry. And a lot of folks have looked into the terpenes for years now, decades really, mainly because they're the most abundant as far as their concentrations go. But none of them really hit the mark as far as some of these nuances that many varieties possess. And so what we're going to be looking at today is this tiny sliver coming off the aroma compounds part of this chart that we generally refer to everything that's basically not terpenes as flavorants. And specifically in this talk, we'll just focus in on a subset of these canasulfur compounds, these sulfur-containing species that produce really potent aromas. And so, you know, again, cannabis produces a lot of different smells, depending on the variety, depending on how it's grown. And a lot of people, again, have focused on these sort of terpenes. But if you look at these terpenes and if you ever have them isolated and be able to smell them in a lab, none of them really have that really potent, gassy, skunky scent that many people really are looking for and kind of use as a quality metric for freshness as well as kind of maybe potency. And so that led us to, you know, hypothesize that there's something else beyond just these major terpenes that are generating these aromas. And so when we first started this research back in 2019, we were just, you know, thinking about this intuitively, you know, as chemists and just as people really. And we were looking into nature. And so it's well known that a lot of sort of potent aromas out there in nature are produced by compounds that have sulfur in them. And so a great example of that is garlic as well as onion. But in the case of garlic, two of the most important VSCs, so volatile sulfur compounds that contribute to its really pleasant fragrance when you cook it, when you grind it, etc., are diallyl sulfide and then diallyl disulfide. And so having that sulfur in there really kind of packs the punch. The same thing with actual skunks themselves, where the chemistry here has these thiols, 3-methyl-1-butane thiol, 2-butene-1-thiol, and there's a host of others as well, but these are some of the most important. But what's interesting here is the structure on the bottom left is actually almost identical to that in cannabis that I'll show you. The only difference being that cannabis produces a compound with a double bond in it versus all single bonds. And so the instrumentation that we used for this, it's fairly advanced. I'd say testing labs wouldn't really invest in this sort of thing. And so I'd say I'm pretty lucky being able to do a lot of exploratory research here at Abstracts. But basically what we have are three main detectors. We have mass spectrometry that's used for actually identifying these compounds, getting their chemical fingerprints. We have an FID used for quantifying the non-sulfur species. And then really the key for this work was the sulfur chemiluminescence detector, because I'll show that it basically simplifies the problem greatly if you suspect, as we did, that the compounds that are really important for this aroma contain sulfur. And so we use two-dimensional gas chromatography versus traditional GC gas chromatography. And just to give you a quick overview of how this works, on the left, we can think of a cannabis flower or product as having a very complex combination of different compounds leading to its specific aroma. Using traditional GC, you separate these essentially by compound size or boiling point, and you end up with a graph that looks like the one in the bottom middle. This slide right here, what we're showing is basically conceptually what we're doing when we use two-dimensional gas chromatography. And so the last thing I was discussing is that in traditional GC, such as that found in testing labs or whatnot, you end up with data that looks like the one in the bottom middle, where you have this trace that shows these peaks and valleys, which indicate basically different compounds. And those on the y-axis indicates response, so basically how much of that compound is present. In 2D GC, we're separating not only by compound size and boiling point, but also by polarity. And what this does is basically deconvolve the data such that we can pull apart things that are still chemically similar that we might not be able to get very clean spectral signatures for in traditional GC. And so instead of having a graph in the middle, we have something like that on the bottom right, which looks like essentially a heat map where each of those little peaks or those smears indicates an individual compound. And so you'll see immediately is that the complexity of cannabis and its volatile constituents is incredibly complicated. And I think that's been assumed and known for a long time, but I think this graph really illustrates it well, just how much is going on in the case of cannabis. And so when we did this study, in essence, what we were doing is we're using the three detectors kind of working together to solve this problem of what makes cannabis gassy or skunky. And so on the top left is the data trace from our sulfur chemiluminescence detector. And what you'll notice is that there's not too many peaks in this data. I highlight probably about 10 here in this sample. Whereas if you don't have the SCD and you're basically trying to hunt these down with no knowledge of where they are, that would be the bottom graph, which is the mass spec, which shows you everything. And so looking for these specific analytes with no information what they are ahead of time would be very difficult. And so the SCD is basically like a cheat sheet for us where we can see them in that data and then go to the mass spec, look at what their spectra looks like, and then identify what they are and then quantify eventually. But one aspect of this is we wanted to answer the question of, well, this chemistry is related to the aroma of products, and so we need to relate that back to essentially what do the humans say when they smell these samples, so that we can kind of draw correlations between specific chemical groups and that aroma. And what we did is we got a sensory panel together, and we procured a bunch of different varieties from around the LA area. And all we did was have them rank based on how potent or loud is this product to you, right? And so everybody recorded their scores, and this is how it looked. And so at the very top, we have Baccio Gelato with a pretty small sample age, so it's pretty fresh. and a very high olfactory score. And on the complete polar opposite end, we have blackjack, which still fresh, but it was ranked as basically having none of that potency that we were looking for. And so what we did is we basically went to the bookends to see, well, what is chemically different between these two that have a very different aromatic quality as ranked by the panel. And what you can see here is that the STD data shows very clear differences in the data. And so these VSCs show much more intensity in the sample that was ranked to be more olfactorily potent versus the one that had much less intensity. And what was really cool about this is that we could actually track. On the right is a graph where I'm pointing at the peak for VSC3, just shown in a 1D plot. And you can see that that peak intensity over the course of the samples, when ranked from top to bottom, most aromatically potent to least, basically concomitantly decreases as a function of those samples. And so that was very good evidence for us that these compounds correlate with the aroma that people are describing. And so something else that was kind of neat about this is a lot of these compounds, or a few of them at least, have rarely been described in nature before. And so VSC3, which is prenylthiol, that's one of the key contributors to the gassy, skunky scent. It's known. It was in the databases that we are indexing against. But the other ones, actually, none of the other four were in the databases. And so we had to solve these basically by pen and paper based on what the data actually looks like here. And so we were able to do that. We had them chemically synthesized, and then we validated their their data on the GCs to confirm, yes, these compounds are indeed correct. And we also did sensory on each of them, and they're all extremely potent. They all have that skunky nuance, some borderline on the more alaceous sort of aroma, so kind of more like garlic or onion-like. But they're all extremely loud as far as their aroma potency goes. And so the two most important ones really that we found kind of that track the most, both in concentration as well as that correlation to the aroma, were these two shown here, this VSC3 and this VSC5. Something else that was interesting that we found is, what is the relationship between certain dominant terpenes and the concentration of these compounds? And really what we see is that there's minimal relationships to these, except for terpinolene-rich varieties, which I'll go get into in a little bit. So what that means is that you can have limonene-rich varieties, you can have myrcene-rich varieties, you can even have ocimene-rich varieties that we've measured, caryophyllene-rich varieties, that can have a wide divergence of the potency and the amount of these compounds. And so there's not really a clear correlation between, okay, if I have high myrcene, I will have more of this gassy aroma. You can actually have high limonene that is comparable to that. And so that kind of goes against what a lot of people have been saying, or traditionally thought that. I think a lot of folks associated myrcene with OGs because it's one of the dominant terpenes there, but also typically OGs have a lot of gas in those aromas. But really, it's this data kind of shows that myrcene is kind of benign in the context of that aroma. One of the cool relationships we built when we did this is that the VSCs in cannabis are remarkably similar to those in garlic. And so these compounds in garlic are some of the ones that actually engender it with some of its medicinal value. And so it makes us wonder if perhaps these VSCs in cannabis might as well. And so we are working with a university looking into some aspects of this. The other thing we were interested in is, once we knew what these compounds were, how do they change during plant growth? Can we actually track these as a function of time and then briefly afterwards? And what we found is that, yes, we can definitely track these VSCs as a function of plant growth. And you see this rapid rise in all of them towards the end of flowering, and then in cure, by far, they're the highest concentration. And then there's a rapid drop even after just about a week of storage, after they were cut and trimmed and whatnot. So I think this is really informative, not only for producers of cannabis, cultivators, but also it highlights that packaging could end up having a really strong influence potentially on retention of these compounds, which, again, if people use this for a quality metric in cannabis, it's pretty important. So we're actually going to continue this study, looking at basically the curve going further into time into the future to see how do different packaging conditions actually influence the retention of these compounds? We then did vape products because that's such a huge market share, within the cannabis space. And yeah, I mean, these things come through really nicely in BHO extracts. That's what we were measuring here. Interestingly, this prenyl thioacetate was actually higher than VSC3 in some of these cases, which is interesting, giving a slight different nuance of that sort of gassy aroma when typically VSC3, the prenyl thiol, is higher. And so I'd mentioned that the CSCs typically are kind of not really correlated to dominant terpenes. That's true except for the one case of terpinolene-rich varieties. And so what I've shown here is a really nice graphic from a paper by Nick Jikomes, who was at Leafly at the time, who basically sampled about 10,000 plus testing lab data sets and looked at what does the kind of the chemistry look like from a terpene perspective across the whole United States. And what you find is that there's these two main clusters that you get. You get this green cluster shown here, and then this red cluster. The red cluster is unique because it's terpinolene rich. And what's so interesting about this when I saw this paper come out is this correlates very strongly with what we see with the canosulfur compound concentrations. And so essentially these CSCs are almost absent. Very rarely do we see these in terpinolene rich varieties at all. But they're all over the place in the green region. And so those would be myrcene rich, caryophyllene rich, et cetera. And so I think this, leads to some really interesting questions, which is why do these terpinolene rich varieties not produce these compounds? And could, eventually breed them up if people wanted that aroma? Or in the case of the other group, could you breed them out? So a lot of cool questions, I think, coming out of this work that we did a few years ago. And then the last thing is I had mentioned earlier is, what is the time dependence of these compounds as a function of time? And so if you have very fresh flower versus aged flower, what does this curve look like? And so this is the packaging study we'll be doing next year. That'll be tracking these compounds as well as terpenes to show that, our hypothesis is that these volatilize more rapidly than terpenes, and therefore that sort of freshness will be more rapid than if it was just terpenes driving the aroma alone. So I'm very excited about that study. I think it'll shed a lot of light on what, as far as kind of shelf life stability and maybe setting benchmarks for, best buy dates, that sort of thing. And so, just to wrap up, we've discovered these new compounds that are the real origins of the gassy, skunky aromas of cannabis. They're in tiny concentrations, but they have a very large odor impact. And then, during flower growth, we can see that these things rapidly increase, and then during curing, they maximize, and then they drop fairly rapidly after that. And so maximizing that retention is, a key thing, I think, for everybody involved in this industry if they like that aroma. And then, future work, what's the medicinal aspect here? What's the genetic explanation for why the terpinolene-rich varieties don't produce these generally? And what are the other possible VSCs that we haven't detected? And we'll be talking about that probably in our next talk, a whole other subset of compounds in cannabis that produce an entirely different type of aroma that contains sulfur. So yeah, I'll just thank everybody, and I'll take any sort of questions that the panel has or any of the audience.
Fascinating.
This is fantastic, man.
Cool, thank you.
Yeah. So it sounds like the smallest part. If maybe I'm not understanding this 100% correctly, but like the smallest part of the terpene is actually the smelliest, or the ones that are the smallest are the smelliest. Yeah.
So based on concentration, more or less, correct. Mm-hmm. So to give you an idea, a lot of terpenes in flower will test maybe at 1 to 2%, something like that. But these compounds are often sub 0.1 ppm. So, they're orders of magnitude in lower concentration than the major terpenes that you see. And that's why I've seen so often on social media and just kind of general discussions where a lot of cultivators and breeders will look at these COAs side by side for two totally different smelling flowers, mm-hmm. and say, why do my COAs look identical, but then they smell completely divergent, right? And so these are part of those compounds that testing labs just don't test for right now, that is something we're also doing is we're developing methodology for traditional gas chromatography systems so that we can port over this sort of testing to testing labs so that, if you go to a shop in Oregon, you can actually get maybe like a gas factor or a skunk factor on the packaging that, translates this chemical information to a metric that you can actually sit there and, maybe make purchasing decisions on.
Mm-hmm.
I have a question. So
Yeah.
you were talking about the difference in the age and people's reaction to how loud the smell was or what they were receiving, right? And there's been some discussion between what the true terpene profile of a plant is, whether it's the fresh growing or freshly harvested or the actual dried and cured. Did you look into that, and what do you think plays into that?
So when we did the study looking at the over time, just the curve, we didn't look at the dominant terpenes. We were just focused on the VSEs because that was kind of the main aspect of the paper. But in the upcoming packaging study, that is essentially the exact sort of thing we want to look into, which is, at week 3, let's say, week 7 of flower, right? What does a panel rate that as far as its aromatic character? And then what does the chemistry say? Then week 8, week 9, however long, the variety has to grow until you have to, harvest it. And then after that, we're going to do multiple sample types as far as the packaging goes. And so we're going to be doing basically Mylar bags, the super popular out there. We'll be doing glass jars because that's also pretty popular. And then we'll be doing Ziplocs. Ziplocs because a lot of people still put their flour just in typical Ziploc bags, right? And we have some early evidence already that Ziplocs are absolutely terrible for retention compared to the other two. And so I think that's like something kind of obvious. A lot of us would kind of already know. But, I think it'll be nice to definitively kind of show, well, what is the rate of decay of not only the terpenes like you mentioned, and then that quality related to those, but also these as well. And so that paper, I'm hoping we can publish that by the end of next year. That'll be a really nice one, I think, for, end consumers.
Okay. Well, I'll be patient. Don't forget the good old ball jar.
Oh, yeah, that's true. Yeah, the thing is, we don't want the variables to explode too much as far as, all the things we want to test.
Mm-hmm.
Do these volatilize at low humidity, even in low temperatures like terpenes?
Yes. So to give you an idea about volatility so prenylthiol, which is probably the most important one in there, its vapor pressure is about 4 times that of myrcene. So what that means is its rate of off-gassing into the actual atmosphere is probably about 4 times that as myrcene. So I think that's probably contributes to why that skunk and gas aroma can persist so far away. Right, very rarely would probably say, "Oh yeah, I smell myrcene down the hallway," but you almost definitely will say if somebody has something very loud, down the hall, that it smells skunky, right? And that's because these things have very high vapor pressures, and I think that's the trouble with, the packaging aspect is that these things want to go into the gas phase, and so maximizing them through growth and then retention during the curing stage. I think there's a lot of research that could be done there as far as varying the curing process, just because it's so much of an art form still in so many ways. And then you mentioned moisture or maybe like water activity. I think there's going to be some interesting relationships there as well. That's one of the variables we'll probably try to control for, and so it'll be cool to see if there is sort of correlations between that.
Yeah, the place I see really people like, especially commercial growers, dropping the ball is. Even when they do a good job in the initial dry phase, they then store them in these black and yellow bins in places that may be cool, have no humidity control, move them from that place to trimming and back and forth and packaging, all these different phases with no humidity control. And it's really important that you don't just dry with humidity control, you store with humidity and temperature control, move your product from drying to trimming and processing with temperature humidity control, where you keep it with that same temp and humidity control while trimming, something back to packaging. Every one of your environments, like you should have an airlock on your facility. Every one of your environments should be completely temperature controlled. It's of what make your cannabis the most amazing in all of these touch points and movements between touch points.
Yeah, no, I fully agree. And I mean, I think that I think you're right that there probably could be more rigor in controlling those sort of variables. And I think part of the reason is there's no real hard evidence yet for what is ideal yet, right? And I think that's something that a lot of people.
I mean, there might not be peer-reviewed evidence, but there's a wealth of evidence of what actually works, and I could point to people who have weed that they store for a year plus that's perfect. I could put it right in front of you. So those people would maybe be a good resource for you to create more peer-reviewed evidence, which I understand when we're moving scientifically, we need that to really say a thing is a thing. At the same time, one of the biggest things is the rush for exponential generational wealth and all this bullshit that came into the scene in the last few years. People with the big watch whose dad gave him $1 million to become an entrepreneur pushed a lot of folks aside that actually have this knowledge and have been doing it. What we've seen, and I think Dr. Ian, I'm not sure, but I think you can you've seen this. I know everybody else on the panel has talked about this. We've seen cannabis quality fall off a cliff. It's because all of these people came in telling us how it was going to be that don't actually understand and didn't take a moment to talk to people who have been doing this as a craft for decades. I'm not trying to be rude in my pushback, but I'm just saying I actually do think that the information is there, and it may not have been formalized yet into studies, but the information is there.
Yeah, no, definitely. And, we work closely with cultivators and breeders. And so a lot of that information, they've shared with us. It's just one of those things. I think that it'll be nice to formalize, what exactly works best, right? And you're right that a lot of people do have their art form, and a lot of it might be scientific for many of these. They just keep it close to the vest. But for me personally, I just think it'd be nice to verify, showing curves essentially of these compounds under these different conditions to prove what everybody's saying. And a lot of, I think what we've published is a lot of people would say, well, no shit, Sherlock. But it's like, well, a lot of people have suspected much of this, but nobody had actual hard evidence, right? And those are two very different things, right? And now that we know the chemistry, we can at least track these things in a systematic way and verify that, hey, grower A does it better than everybody else or whatnot. So I think that's one of the
scientific rigor. You have to start at the start, and so I understand that.
Yep,
we have to start at 1, move up to 2, then to 3. So that makes perfect sense. And I'd like to say, I'm not sure if you're aware of Hyphae Labs, but I see Reggie Harris and Hyphae Labs some really cool things on the mushroom side that are kind of analogous to this in testing mushrooms for drop-in potency of psilocybin and psilocin over 6-month and 1-year periods, and also doing stems versus caps potency testing. I think a lot of this stuff has been knowledge, but has really been guarded as trade secrets, and is finally starting to see the light of scientific rigor. For that, I'm really thankful.
We have a question from Dr. Mark in the chat. He said, do the sulfides oxidize on aging to sulfoxides, sulfonates, and sulfates?
So we haven't seen that, but I'll also mention that depending on what their concentration is, if our detector is not sensitive enough, we wouldn't see that. The other thing is, I don't know if those would be stable under some of the conditions that we run our experiments at. Just like our inlet temperature is pretty hot. I don't know what the stability is of those. But no, we haven't really seen that at all. What we do see, though, is typically, generally speaking, older cannabis has less of these, right? So if, in one of the early plots or graphs I showed, there was a table with kind of sample age. And if you kind of look at that, oftentimes the amount of the concentration in those samples that are older tend to be lower. It's not a hard and fast rule because obviously certain varieties produce these in greater concentrations to begin with. But it makes perfect sense that if these things are volatile, you will lose them, to evaporation or, potentially to oxidation, as Mark is saying. But that's something we haven't observed yet in our data.
Cool.
Oh, son of a bitch.
Oh, son of a bitch. That's not scientific.
No, sorry. My headphones are falling off. I was listening too hard.
In Cannabis Science musical chairs, I guess I lose because I have to jump and actually go to work. I love you guys.
Much love,
Ian, please come on again. I really enjoy your talks, and I'm really to see you putting some scientific rigor behind quality of cannabis, because again, I think this is what we really need to be shouting from the rooftops about. As the thing that got me into cannabis and that really keeps me moving with the plant is my love for the sensual experience, the look, the smell, touch, taste, and then the actual experience of getting high. Love you guys. I'm going to jump. Jason, Jenny, love you guys. Cool. Dr. Ian.
Much love. Thank you so much, Matthew St. Germain.
Jason, you don't have any questions?
No, I do. I have a ton of questions, but I thought I saw another question, and so I wanted to
I have another question, if that's okay.
Go ahead, of course.
I've actually got two. So Vermont Alternative said, so is off-gassing what makes it loud?
Yeah, I think so. In order for our noses to detect something, it has to be in the gas phase, right? And so that's basically what you're smelling when you either stick your nose in a jar or, again, if it's kind of seeping out of a container that's not airtight down the hallway. And so I think that's kind of the struggle here, is that you want, people really like this aroma, I think, and that potency. But at the same time, every time you're smelling it, technically you're losing some of those compounds as well. So down the road, you're not going to have that same sort of impact. And that's why I think really on the cultivation side, if people want this aroma, breeding for this specific analyte as a target could be very valuable, right? Where if you breed up, a bunch of phenos or something, and then you're able to quantitatively measure, okay, this one over here has the greatest concentration of these compounds, well, then now your starting point is higher, right? And so as it ages, you're most likely going to have a sort of enhanced sort of aroma potency over time versus pheno or a variety that might have less aroma potency or to begin with, lower concentrations.
Awesome. And Ben LeBone from Deschedule Now says, is aroma the chemical pathway to establish medical efficacy and support opportunities to cure disease?
I don't know. That's a tricky question, I think. What I will say is it definitely dictates sort of preference. But preference doesn't necessarily correlate into efficacy within the body. The one thing we are doing is looking at these, I'd mentioned, in relation to certain ailments with the university. That's hopefully will be published, in the next year or so. And so, maybe that'll shed some light here. But I'll mention, I think to some degree there might be correlation, but remember, correlation doesn't equal causation, in the sense that I think a lot of folks will say that, really fresh, really potent cannabis works better for them than something that's super old and, lacking any of that luster. And so whether or not these compounds are the reason for why they might provide enhanced benefits for a user, I don't know if that's the case, but they might be a good indicator for other things that are still present when it's fresh versus not fresh. And so in that regard, it might be kind of like a corollary to what the actual sort of medical applications might be at that point.
Okay. And then Rico was asking if gassier strains have a higher propensity for mold growth.
Oh, that's a great question. I have no idea. That's super interesting. I'll mention something that's kind of cool that recently I'm writing a white paper right now looking at neem oil, because a lot of people use neem in the context of cannabis cultivation. And what's really interesting about this, we ran some neem oil on our GC the other day, and there's actually quite a bit of volatile sulfur compounds in neem. And I think if anybody has ever used neem, it has a very specific sort of scent. It doesn't really smell good to me, but it's very potent, right? And guess what? VSCs, just like in cannabis. But the reason I'm bringing this up is that a lot of people use neem because of the insecticidal or pesticidal sort of, the natural properties that it has. But what's really fascinating is that a lot of people attribute that to some of the larger compounds that are in neem oil. But it turns out that folks have actually looked at these volatile sulfur compounds in neem oil with respect to their own insecticidal sort of properties. And even the VSCs showed some sort of activity against certain types of pests. And so I thought that was so fascinating, because basically what that means is that neem oil, it's not just the azadirachtin, the main component that people focus on to make it insecticidal, but actually these VSCs might sort of influence it. And so wondering whether or not these VSCs can influence pests or maybe mold or fungi, what have you. I think it's a really interesting question, and I think there's opportunities there for looking at these compounds kind of in isolation with regard to activity against specific maybe fungi or that sort of thing. So that's a great question. I just don't have an answer to it, but would be very interesting to figure out.
Awesome.
Have you done any studies with these terpenes? Because I'm willing to bet that there's a big difference between the type of terpenes from the same flower, whether it's grown indoors or outdoors, Dr. Ian. Because
I mean, I've never seen a study doing that very rigorously, at least for these VSCs. I mean, well, nobody's really done that because they're so newly discovered. But that's a really interesting question, because I know there's a large kind of debate, or a lot of people who are very pro sun-grown flower, right? And there's a few studies showing that there are differences there, at least in like the terpenoid content, cannabinoid content, that sort of thing. But nobody's looked at these VSCs yet, and I think that would be a really interesting avenue of research to pursue, because that could further bolster the sun-grown argument, right? Like, is sun-grown truly better in the context of louder flower? It would be a really interesting study to do.
Well, at the same time too, because I'm a big believer that outdoor flower decays at a much faster rate as indoor flowers do, as long as both are stored properly.
Interesting, yeah. And when you say decays, in what way though?
Well, because cannabis is it's dead, and so it's its freshest point at when it's finally dried and cured. Other than that, it's basically a dead organism and is constantly decaying, just like a human body would over time.
Yeah, I mean, that's interesting for sure. And again, I mean, I think this is just adding to the long list of experiments that we could do to kind of verify some of these things that we were hypothesizing about. You just did right now, right? That you've noticed anecdotally this sort of difference between indoor and outdoor. And it would be great to validate all of these sort of things. And I think those sort of studies will be much more feasible when the testing labs can test for these compounds, right? Because cultivators could literally do these experiments basically in-house. And then send the flower to a testing lab. We don't have the bandwidth to do that sort of study right now. But I mean, I think that would be great marketing if they can show one or the other has a difference, right? From a quality standpoint. But also, you don't want to generalize too much, because where it's grown is where as well. Like, that concept of terroir. That's a pretty big concept in the in the wine industry and the hops industry, and I think probably in the cannabis industry too, right? Growing in Southern California versus Northern California, and then Oregon or Washington, all of those they're all sun grown if they're outside, but their environments are completely different. So there'd be a lot of variables to control for, but I agree that would be a really fascinating thing.
At that point, if you break it down that farther, you would have to break it down by elevation too at the different points.
Oh, for sure. Yeah. I mean, all of those things should be parameterized within the experiment for sure. Like, that way you can draw meaningful relationships between, all of the properties of your study to pull out, well, what is really affecting the result of this study.
With now also too, I would imagine that it would work the same way, and we could go down another like that, because I'm a believer that outdoor is generally better for making hash, whether that's rosin or BHO or any of that. I'm a believer that's because I feel like outside something different happens with the terpenes than inside. But as far as for actual smoking of flower, I'm a big indoor all day fan, and I just feel that the plant doesn't experience enough of the roughness that the environment creates in an outdoor situation, and so it kind of like has like this perfect life in the perfect climate and the perfect temperature, and every day is perfect, and so that enables that to preserve longer.
Yeah, I mean, that's another interesting observation you have. I mean, rosin, I mean, that's one of our favorite matrices to measure, just because it's concentrated relative to flower, right? And so we can actually see more stuff when we measure rosin versus flower. But one of the things, and this would be a great parameter to track, to be honest, I'm glad you asked this, is how was the flower grown, right? Was it grown indoor? Was it grown outdoor? Because if we can track that parameter, actually over time, we can probably pull out some relationships between these sort of concepts that you're mentioning here. So yeah, that's actually a great point. I'm going to write that down.
Amazing.
I mean, I think that makes sense, right? Because we use outdoor flower traditionally for concentrates because the cost of production, right? It's easier. You can create more mass, whatever. What?
That's another reason.
Yeah, that's the main reason, right? It's cost of production.
Yep.
But also, if you're looking at terpenes, those are the plant's natural protection system, right? So, you're not going to have necessarily the same conditions indoors. It's not going to have certain bugs attacking it that it's going to need to produce certain terpenes to repel, et cetera, et cetera. So maybe that's worth looking into.
Well, I think it still produces the same level of the terpenes and the protectant, but and that's why I think for concentrates, some outdoors are always a lot terpier than the indoor version of them, is because it's not producing specific ones because it's not feeling those threats. So in essence, those muscles aren't being used because there's nothing there for them to do.
Yeah, you didn't put your sweater on because it wasn't cold yet.
Exactly.
Yeah, and that opens up another can of worms in the context of what stress is good and when, right? Because stress on plants can actually maybe potentially lead to greater production of certain volatiles, right? And so, there's just so many questions, knowing this chemistry that we could ask and so many variables we could try to test. But one thing we did a while back was looking at basically nutrients in the context of increasing these concentrations. And so we were using potassium sulfate, which it's a sulfur source. And so we were thinking that excess potassium sulfate might lead to more VSC production, in the experimental plants versus the controls. And what we found is that at least with potassium sulfate, we didn't see any significant increase in production between those plants versus the ones that had the normal regimen. And so I thought that was interesting because there's a lot of speculation or discussion that sulfur can increase these metabolites, and maybe when people say that, they're referring to elemental sulfur versus salts of sulfur. I think a more rigorous and an in-depth study looking at the nutrient aspect would probably be one of the most interesting, to be honest, because that's very easy to control for, and I think could result in some really interesting discoveries.
I think this might be something that maybe some nutrient companies want to sponsor, this type of research, so then that way they could advertise that their stuff produces the best terps.
Yeah.
Right.
Unless it doesn't, Jason.
Well, right. But they're going to pay to find out.
Yeah, very cool, very cool. I think this has been a great segment. I think our viewers have definitely enjoyed it. Some of them have said, "Y'all better stop. I have things to do and I can't stop watching." So, and it sounds like, Dr. Ian, you've got some new viewership from the audience as well, looking for your channel. So that's awesome.
Cool. Yeah, I'm glad I could provide some value here.
Yes.
Somebody needed to.
And this will be a quarterly segment that we do with Dr. Ian Oswald. So, and I already have some other ideas of how we can 100% improve this segment that I'll go over with you after the show, Doctor. I can't wait to talk to you about this.
Cool.
But do we have any other final questions, Jenny?
I don't see anything in the audience. No, I've been scrolling through and trying to be pretty vigilant on those.
Amazing. Well, make sure if you do have any questions from this video that you drop them in the chat once you're watching it later on. We do appreciate your time, Dr. Ian Oswald. Thank you so much for being here today, and thank